Okay, in this video we're going to go over a big data science problem. It's sort of several problems, but it's something common you might see in any kind of business environment, right? So we're going to be selling some things over the course of a year. We've got some concepts, some equations that we need to be aware of. What's revenue? So that's price times the quantity. So if you have some item and it costs a certain amount, or the price is what the customer pays, the cost is what the business pays. So the price is what the customer pays times the quantity of items, right? But then we also have to factor in state tax, all right? So one accounts for the price times the quantity, so you're going to pay that, and then in addition to that, you're going to pay the tax rate on the price times the quantity, right? Then we have gross profit. So this is the price of the item minus its cost. So the cost could be cost of production, or it could be just cost of acquiring it. We might, purchase it from another retailer and then sell it at a slightly increased price to make a profit, right? So the gross profit is the price minus the cost times the quantity of the items, right? And then net profit is the gross profit minus any expenses you have. So this would be expenses would be like monthly expenses, like your rent, your bills, utilities, all sorts of things like that. Anything that goes into labor, any kind of expenses on top of what it takes to actually purchase the items themselves, right? The costs. All right, so these three items are going to be brought up several times in this data, and so we've got a few different sections here. We've got customer data stats, sales data, so this is the monthly stuff, and then annual stuff. And again, these are sort of common questions that you might encounter in any kind of business. You want to figure out what the total revenue is, what the gross profit is on a particular month, what the net profit is, what month is our best month so we can prepare for it, what month is our worst month, that sort of thing. And then annually, you might look at what products sell the best, right? If those products are selling the best, should we produce more of them? What products are not selling? Should we move away from those products? This is all very practical stuff that you would encounter in any kind of business, right? So where are our data files? They're located here. I've got this highlighted, and I'll post this in the comments too, so you can play around with this stuff. The idea here is we have a CSV file, comma separated values, customers.csv. We have expenses, so these would be the monthly expenses. We have our products that we're selling, and then we have a table for the tax rates, and then our sales data. So our sales data goes from January to December, right? And so there's 12 of these. All right, so what we want to do is we're going to have, for each one of these questions, we're going to have a Python file that we're going to kind of go through and try to solve the problem. Now we also have the answers here, so we can check to make sure that the answers to our questions, we're getting the proper results, okay? And we've also got this utilities.py file, and this is going to allow us to have any kind of functions in here that we need to reuse in our individual Python programs that actually solve the individual questions, right? So these are just going to be filled with utilities, helper functions, and that sort of thing. All right, so the first thing we kind of want to do is we want to download the data. In this particular set of data, we are not going to be opening the files directly. We're going to be using request.url. I'm sorry, we're going to use urllib.request to make these requests online. So you see that the files are located on a web server, right? And so we're going to access those files. And because this is big data and we don't want to turn in all of this data, we're just going to use that method to access this information, so we don't have to copy it all the way down and transfer the data itself. When we have our solutions should just download the data as they need them. So someone could run our program and it will just work. They won't have to download the data first. However, that said, it is important to be able to look at the data. So we are going to go ahead and download the data just so we can look at it, but our program isn't going to use those files. Those files are going to be just for us to look at. All right, so the first thing we want to define here is download data. Okay, and this function is basically just going to go through and locate each one of these and download it, and we're gonna create a folder in here called data and just put it in there, and that way we can just explore the data. So that's going to be the first step here. All right, so we're going to need to import a couple of things. So we want to import url lib.request and import os so we can make directories and check to see if they exist and that sort of thing. And then we'll also have name equals main. Okay, so since we're going to be using this utilities file and we're going to import it into our other files, we need to make sure that we have this area where we test the code. So this code won't run if you import utils, but it will run if you run utils directly. So that's what this little snippet does. So what we need to do here is we're going to just download our data. And so this is what we're going to do when we're ready to test it. So how do we download the data? All right, so first we need to decide where we want to put the data. So we have a path prefix. All right, this is basically just, where do we want to put it? We're going to make a folder called data, and then we're going to check to see if that folder exists. So if not os.path.isdir, if that doesn't exist, right? So os.path.isdir tells us if it's a directory. If it doesn't exist, then we're going to create it. mkdir path prefix. Right. Okay, the next thing we want is URL prefix. So all of these files share the same sort of prefix here. So I can copy that over and I can say URL prefix. And then I have several file names. So files is going to be an array, and I can say customers, products, tax, expenses, okay, and then these are CSV files, so I'm going to have to add that .csv at the end. All right, and then we have our monthly sales files, right? So files equals files. So I'm going to concatenate the existing array here of file names, but then I need to include all of the ones like sales 01, sales 02, etc. So what I'm going to do for that is use a list comprehension to create a list real quick. And I'm going to say I have a format string here, sales, and then a hyphen. And what I'm going to put in here is some I value. I'm going to have the range function generate the I values from 1 to 13. So it never reaches 13. So this will give me the values of 1 to 12. But I want to format this so I have a 0 in front. So the way I can do that is if I'm formatting something with a format string, I can use a colon after the thing I want to be injected into my format string and specify formatters. So the formatter here is I want to pad with the 0 character. I want my data to be all the way to the right, and the padding, which would be to the left, right? So the arrow indicates where your data is going to be, and then what window of characters am I using for padding? So in this case, I want 2 characters. So if my I value is just 1, I'm going to push that 1 to the right. I'm going to put a 0 in front because we have a 2 character window where the padding applies. If I did this, we would have 0, 0, 1, right? This is just 0, 1. All right, and then I'm going to add the .csv. Actually, I'm not going to do that yet because these don't have the .csv. All right, so this is just going to generate the list. So I have to say for I in range 1 to 13, like that. So this is called a list comprehension. You have sort of this for loop idea. I is going to go from 1 to 12, and then we can inject I here. So this is generating a list that's going to be the result of running this for loop and producing these values. So the thing on the left here of the for syntax is what's added to the list. So this is generating all the sales -01, sales -02, etc. And then we're concatenating that with our existing list of files. All right, so hopefully everybody's familiar with those. And then we'll say for file in files, we need to use our URL lib.request. And we're going to get our URL. So we have our URL prefix, which we need to inject in here with the format string. And then, see, it has a slash after it. So now we just need to add the file. Okay, and then this is going to give us or .csv. Okay, so this is going to give us this URL, then customers, and then a .csv. And so this should go retrieve our data. All right, so the way you use URL lib.request, you actually have to say URL open is the function. And usually you do this kind of like how you do this with a opening a file and writing data. So you use the with keyword. So with URL lib.request URL open as my request. Then I'm going to say data equals my request dot read the data, and then decode the bytes as UTF-8, which is the character encoding. So that's the most common character encoding on the web today. Most things should be in UTF-8. If they're not, they're probably old. And then, so we have this data, and then we're gonna use with keyword again and open a local file, right? So our local file is going to be our path prefix up here. And that needs to be in curly brackets because we're injecting that into our format string. And then it has a slash after it, so we can just specify our file and then our .csv. So we're going to open this file, and we're going to open this for writing, and then we're going to say as f, and then f.write this data. So the data that we got from up here, we're going to write it here. All right, and that's our download function. Not much to it. Prefix, create the directory if we need to. Here's our files. For each file, download it from the internet and then write it to the proper location. All right, so let's run this. Plus X. And so I'm going to run my util file, URL lib.request. I misspelled URL open. URL open. And I have my network graphed up here at the top, and you can see there's a bump in network traffic, and that's me downloading. Here is the data file, and here is all of our information. So we downloaded all of this, and this is just, again, we're just going to use this to look through the data. We're not going to actually open these files because we want whoever has this program, we want it to download it for them automatically, but this is just for us to look through as we're solving these problems. Okay, so we look at customers. We've got some information at the top of a CSV file, comma separated values. So usually the first line is the labels, and customer ID, first name, last name, street address, city, state, and zip. All right, so now as we go through here, we want to kind of look at the data and see if there's any issues. A lot of times in big data analysis, there are problems with the data, and you have to be aware of that. And sometimes it's simple things like different fields are switched, and you have to correct that if it's possible. Now here we have a comma, comma. That means this field is just missing, right? So sometimes there's just missing data. And if there's missing data, and it depends on what the problem we're trying to solve, but if there's missing data, sometimes we can get rid of it and not use it. Other times, if we don't need that particular entry, we can get rid of it. But if we don't need this field, and we can still use the rest of the data to solve whatever problem we're trying to solve, then we would keep it, right? So it depends on what you're solving, but it is important to be aware of the types of issues in your data, right? And we can, scroll on through. And so in this particular data set, there are a few issues with some zip codes and states being swapped around. Let's see if we can find one. Well, let's not. We'll find it programmatically. Okay, so this is our data expenses. So these are monthly expenses. So the month 1, 2, 3, 4, 5, 6. So this would be December, and then this is the monthly costs. We have a list of products. There's a product ID, a price, and a cost. So remember, the price is what the customer is paying for the item, and cost is what we, the business, are paying for the item. All right. And then we have tax information. So we have a state, the tax rate, and rank. Now notice how this is formatted. And we've got NA here. So what do we do for NA? In this case, we're going to make the assumption that the NAs are 0% tax, just because we don't know. And then, it might be a better idea to assume it's a maximum or something. But for this, we're just going to assume 0. We have Alabama, and then notice it's the full state name, not the 2-letter code. And then we have 4 and then a percent character. So if we actually wanted to turn this into a rate, we would have to strip off that percent character, divide it by 100, right? And then that would give us our actual rate as opposed to this as a percent. Okay, so this is going to be an issue too. The states have the long name. So what we want to do is, because we're going to have to compare that here with these states from the customer database, the customer tables. So they have the short name. So we're going to need some way to convert those at some point. All right, now we're just looking through the data. Here's our products. So we've got widgets, fidgets, trinkets, etc. And we have the price and then the cost. Right, and then here are the sales data. So this is how the data is entered into the system. Right, so we've got an invoice number. So each one of these invoice numbers you can think of as like an order, one order. So this is all the 7,500 invoice. So there were 2 items purchased on that invoice, and we have a customer. There's only one customer. It's the same invoice. So whenever it's the same invoice, it's also going to be the same customer ID, and then the date that the purchase happened on, the product that was purchased, and the quantity. So in this case, for some reason, the data was entered. They bought 16 fidgets, and then they rung up 4 more for some reason. So that's kind of strange. But here we've got, on the next invoice, we have a different customer ID. They bought fidgets. They bought 6 of them. They bought 1 bauble. So this is still 7501. So they bought 13 gadgets and 17 doodads. So this is, again, all, you think of the invoice number as basically an order, right? And you'll get some strange stuff like this, but it's still just one order. All right, and this is the data. And as you scroll down, you see this file is quite large, right? So we are dealing with big data. We're not even halfway through it, and we've got 2,000 lines of code, or lines of data. All right, so that's kind of the data that we're looking at, and we're going to pop back here periodically if we need to, think through, how our data is structured when we access it. Okay, so the next thing we want to do is write a function to read this CSV data in. There are a lot of tools for this already. Pandas is a really good one, but it's important to kind of play around with this stuff yourself, and then you can learn a little bit about why things are needed. It's a good coding practice to build your own tool first, and then once you understand all the problems involved, then use something that's already been developed and tested really well, and you'll have a better appreciation for how it works and why it works and what all it can do. All right, so that's what we're going to do first. We're just going to create a read CSV. So let's define a function read CSV, and this is going to take in some URI, and we're going to have a column separator. The column separator by default is comma for comma separated values, but not all CSV files use the comma. And then we're going to have a row separator, and our row separator by default is going to be the new line character. And we might optionally, we might get back to this, add a primary key. right? And so what we need to do is what kind of data structure are we going to use when we read in this information. So we've got all this file data, and do we want a list of lists? Do we want a list of dictionaries? What makes the most sense? Probably we want a list of dictionaries so we can access what we want. But if we had a primary key, then we could have a dictionary of dictionaries, right? So what do I mean by that? If we look at the data, say we look at customers, okay, it looks like all of these customer IDs, and ID is a keyword identifier, so these should all be unique. So this could be a primary key to access one individual value, one individual customer record. Now, why would we want to do it that way, to be able to access these by their ID as opposed to scanning through the entire list and finding an ID? Well, it's because these lists are very large, right? So if I can, I probably want to, if there's a unique identifier, right, I probably want to use that to access the customer information record rather than having to search for it. Now, why can't we just use the first and last name, right? That's because two people can have the same first and last name. So we need some sort of unique identifier. So it looks like that's already in the system. So as long as these are all unique, we should be good to go to use that as a primary key. All right. But to start with, not all of the data we have is going to have primary keys, right? So for example, the sales data, there's no primary key. There's invoice numbers, but they can be duplicated. There's customer ID numbers, they can be duplicated. There's dates that can be duplicated, right? So there's no unique primary key here. So we can't assume there's always a primary key. So that's why this would have to be optional if we add it. So we might come back and add this. But for now, since we know we don't always have a primary key, the best way to probably create our data structure would be to have a list of these individual records. But we want to probably access the individual values in a dictionary. So we want this entire thing to be a dictionary where invoice number is the key, and then 7500 would be the value. Customer ID would be the key, and then 1600 would be the value. Date is the key, etc. And so each one of these is going to be a dictionary, and then we'll have a big list of these dictionaries. So that's going to be sort of our default setup. All right, so let's go through here. And how can we do this? All right, so we want to check to see if so I used URI here so we can access either individual files or we can access URLs, right? So first we can just check to see if os.path.isFile, right? And then pass in the URI, and if it is, then we'll just open the data. I'll open it for reading as f, and then f.read. Okay, so if it's not, then we want to use the URL lib.request, URL open, and URI as request. And then we'll say data equals request dot read, and then we want to decode those bytes into UTF-8. And if you want more information about URL lib.request, just go to the documentation. Okay, so with URL lib. Right, so we have our data. And then what do we want to do with it? Well, we want to split it up by the column separator, right? So what we start with is a big string. That's what our data is, and we want to get lines of information. So the lines of information are going to be data.split over the new line character. All right, and then after we split over the new line character, and that should actually be the column, the row separator. Yeah, because each individual row or record is separated by that new line character. All right, so we do that. We might want to do something like that strip to strip off any white space at the beginning or end, or any extra new lines in the file. That way we don't have a bunch of empty records at the end. All right, so data.strip.split by the row separator. That should give us the lines. And then what we want to do is kind of make a list of lists. Okay, so we're going to use another list comprehension, and we're going to say for line in lines. What we want to do is get rid of any lines that don't have anything in them, right? So we'll say if line.strip does not equal the empty string. So we're stripping off the characters, and if it doesn't equal the empty string, then the output or the result of our list comprehension is just going to be that line. But let's go ahead and break that line up too. Let's strip and then split over the columns, right? So the column separator is COL-SEP, and that's comma, right? So what we're doing here is we have our lines, and then for each one of these, we're going to make a list of lists now. If we separate over the column separator, so we're splitting over the comma, and so we'll have a list of those individual fields. And for every single line, we do this as long as that line does not equal the empty string, right? So this does two things. It removes all the empty values, all the empty rows, if there are any, and then it also will split each line over the column separator, and that gives us our lines. So this is a list of lists. Now remember, the titles are the first line, so this is lines 0, so this is the list of our titles, and then the individual records are going to be lines, and we're going to go from, it's not including the titles, so we're going to go from 1 to the end of the list. So this is taking a slice of the array. This is just the first list in the array, and that's our title values. If we go to customers, that's this, except we split this by comma, so this is going to be an array of strings, and then everything else is going to be an array of arrays. Those are the records. All right, so once we've got our records, we have a list of lists, but what we probably want, like we said, is a list of dictionaries, right? So we're going to have to return, and we can use a dictionary comprehension here. Return, and so usually the format here is you have some key and some value, some key, some value, and then for I in range length of titles, right? So we need to return some key and some value here, and this is a dictionary comprehension, okay? But we want to do this comprehension repeatedly. We want to do this for each line in lines, right? And so we're going to end up with a list comprehension, right? So what gets returned in the list comprehension? This dictionary. This dictionary is a comprehension itself. So for I in range length of titles, we have titles I. Okay, so this is going to be the key to our dictionary, is whatever value of whatever value we have in the titles list at index I. And then here for our value, we're going to have what's in the record. So whatever is in the record. So this would actually be for record in records, right? Because lines is just the array of arrays, but it includes the titles, right? So we don't want the titles here, otherwise we're going to have a dictionary where there's a title as the key and then that same title as the value, right? So we want records there. So for record in records. So again, list comprehension, the value that's returned is this dictionary. This dictionary is a dictionary comprehension, and we are going through each of the records, and for each item in that record we get the I value, and we get a key from the title and a value for the record. All right, so this is read CSV, and we can kind of test this out. We'll comment out our download data here, and let's just say read CSV, and so I don't have to download everything right away. I'm going to say customers.csv, and so this should return a dictionary, or a list of dictionaries rather. So we'll call this records, and let's print out the records. Okay, so if I print out the records, they're going to be a list of dictionaries. It's going to be really messy. So what I'm going to do is use this asterisk that's going to take all of the elements of this list and apply them as arguments to the print function. And then I'm going to use a separator and say, normally the separator is a single space. So between each item, each argument you pass to print, the separator character is added between printing each one. So we're going to make this a new line character. So between each one of these values, it's going to print out a new line character. So this is going to give us a nicer printout. We'll print records one at a time, so it'll be one dictionary per line. So hopefully this will be a little bit more readable. All right, let's run utils again. Data reference before assignment, line 32. Oh, data equals f.read. Right? Yes. So we're opening something as a file. We didn't save our data there. Okay. All right, so we see each one of these new lines is a record, and the record is basically the title, the first item in our title of the CSV file, and then the value associated with it. The second title, and then the value associated with the record, right? So now we have this nice list of dictionaries that we can work with, and we could do something like, you know, if there's a primary key, then we can make this a dictionary of dictionaries instead of a list of dictionaries. Okay, so that's working. What else do we want to do here, though? For different values, we probably want to have, like this, we want to automatically convert things where possible. So we want to convert to integers if possible, and we want to convert to, you know, floating point decimal values when possible. So we might add another function in here. We'll call this define auto type data. And this is going to allow us to auto type a piece of data. And we're just going to try to convert it to an int. And accept pass. So we're going to try to convert it to an int, and if we do, we'll return. If we get an error, then we're going to try to convert it to a float. Why do we do int first? Because if I have 5.5, I can't convert that to a float, or to an integer, and I don't want to. If I have the number 5, I can convert that to an integer, and I want to. But with float, if I have the number 5, that'll convert it to 5.0. Right, so I want to make sure I do integer first. So anything that can be converted to an integer will be an integer, and then I do float second. And then that way, anything else that has like a decimal point in it is going to be converted. But strings won't, right? So if we have a string, then we're going to just pass. This is probably not the best way of doing things, but we're trying to get through this fast. And otherwise, it's already string data, so we're just going to return that same string data. Okay, so if we have an int, convert it to an int, return. If it's convertible to a float, return. Otherwise, pass. And then otherwise, it's a string, so we just return that. So this is going to be auto type data. We're going to automatically type this data. And so we go down here, and where do we do that? It's in our dictionary, right? So we have a dictionary key, and then we want to auto type whatever data that is. All right, and so we can run this again. And here we see that our zip codes have turned into integers, right? Now, is that appropriate with zip codes? Probably, because I don't think there are any zip codes that start with 0, but that's something you would want to check on, right? So you would want to be careful. And so let's say there were some zip codes that start with 0. I don't know if there are. I don't think there are. But then if there were, converting it to an integer would strip off that 0, and it might cause some problems for us. All right. So what we'd want to do probably is have some fields in here in our read CSV file where we can exclude from the auto typing of the data or something like that. Some additional fields, right? So we can already see this read CSV function could have a lot of extra functionality. We might want specific fields to be converted specific ways. We might want dates to be handled a particular way. There's all sorts of different types of data that we might want handled particular ways, and we might want to be able to define how to do that, right? And the advanced CSV readers like pandas, they handle all of that. They've thought of all of these problems and encountered them, and it's really well tested. However, this gives you an insight into how complicated things can get. Our data is pretty simple, but that's not always the case, right? So if we wanted this to be truly versatile with all sets of data, we would have to account for all the different ways things could be set up, right? So, all right, we can now read the CSVs. We've got the data we need. Let's take a look at our first question. Okay, so given customers' CSV data, what % of first name fields are left blank? Okay, so I need to calculate the %. I think the answers here is just the number, so we'll just divide by that, and we'll fix that up later. All right, so what's the %? Okay, first, what do we need to do? We need to import our from our utils module. We're just going to import everything, and then as needed, we've got sort of these functions that should get our customers, get our products, get our tax rates, etc. So what we're going to do is create these functions in our utils file. Get customers is the first one that we need, so let's do that. All right, we want to get customers, and if we're getting the customers, we need to call read CSV, and then for now we're going to access the customers.csv file directly, otherwise there's going to be latency. But when we finish, we have to remember to replace this with the URL. All right, so we want to read CSV customers and basically just return that, right? So data.customers CSV. And we can do this with all of our basically data types. So get customers, we have get expenses, we have products, and tax, and the last one is sales. And this is monthly sales. All right, and what do we have to do something a little bit different for monthly sales because these items are called sales 01, 02. So we probably want to keep them together, keep the months, or rather separated. So we might, because we're going to have questions that have to do with individual months. So we're going to have a list of values here. and we basically want to go through and return a list of these read CSV sales. So we're going to do a list comprehension here again, dash, and this is going to be I. So we have a format string here. So we're going to go for I in range 1 to 13. So this is going to give us a list of the lists of dictionaries for each month. This I value is not going to be sufficient. This is just going to give us sales 1. We need sales 0, 1, so we have to use the string formatter. We want our data to be to the right. We want the character to pad width to be a 0, and the window of characters to be 2. All right, so that is going to give us our monthly sales. So this is going to be our tax rates. All right, so customers. Let's take a look at the customers. We want to find out what percentage of first name fields are left blank. Okay, so we want to get our customers, and then we can say for customer in customers, and we're going to have a count of blank. It's going to equal 0, and we'll say if customer first name equals the empty string, right? Or we might also even do strip. All right, we probably want to look in our utils file and make sure if we need to decide if we want to automatically strip white space if there's in between the fields. Like for example, if I had space here, I probably don't want that space. That's probably not part of the person's name, so I'd want to strip that off. So we want to probably make sure we do that. If we look in utils, where we are splitting the columns, right, and for each one of these we might want to strip off the values. We can go through those. So this would be record I, and we could do that here, strip. Okay, so that would take care of that, so we don't have to do it anywhere else. But again, that you might want, like if you had the spaces there, you might want them. It depends. So we're making some assumptions, and we'd probably want to make those options available in our read CSV function eventually. Okay, but right now we're just going to see if it's empty string. That's fine. Then that means it's blank, so we say blank plus equals 1, right? And so we go through all the customers, find out how many of those customers have the blank, right? And we're going to be doing this a lot because it's the first 5 anyway, are percentage and what fields are blank, first 4. So we have this field. So we can kind of abstract this out. We can say field is first name, and so blank equals 1, and then we want to print out our result. So we're going to print out a format string, and the way they have it, the 66 missing fields, right? We can mimic that, and then we'll switch and do it the percent like the question says. So we'll say blank missing fields, and we want to tell them which field is missing, and that is field, which is first name. So there are blank missing first name fields, so 66 missing first name fields. So we will test this out. We want to run o1.py, 66 missing first name fields. If I want to convert that to a percentage, I need to divide that by length of customers and then multiply by 100, and then format this. So I want to format this with 2 decimal points. So I want a floating point decimal, 0.2, so 0.00. I want 2 decimal points after this, and then space and a percent sign, because this will be a percent. All right, so let's run that. Let's see the format specifier. Oh, it's just .2, I think. Yeah, so 5.3% missing fields. So that should be 5.30. So what am I missing here? Times 100. Let's see. Yeah. Oh, it's not .2. It's 2F. There we go. .2F. There we go. So this is the precision, right? So .2, so 2 decimal places. So the dot is telling the formatter, okay, I want to specify a certain number of decimal places. We want 2 decimal places and floating point values, right? There we go. Okay, so you can look up these formatting formatters. They're a little bit confusing. I have to look them up sometimes, but they're really handy because we can just inject some values and format it right away, and it converts it to a string to exactly what we want, right? So .2f is going to give us whatever the value is here. That's to the left of the colon. It's going to format it to 2 decimal places, and it'll round it. Now it'll round it with Python's round method, which has some inconsistencies because of the way Python stores numbers. It stores them in binary, and so when you convert them, sometimes there's a rounding error. But this should be good enough for most things. If you need anything else, you probably want to use NumPy, which pandas and other big data tools use. But this is good enough for what we're trying to do. All right, so this gives us the percent, and then for each one of these, 5.25, we basically just copy this, right? Duplicate. What's the next problem? What percent of last name fields? So we can just do last name there. Make the file executable, O2. And just like that, we have last name fields. And if we want to match it to the data file, the answers, so these answers are wrong. They should be the percentages. We'll fix that up. But so 40 would be correct if we did this right. And so it is 40. So now we'll go ahead and do the percentages. But you can continue with the other ones pretty easily. Just copy and paste. Let's skip on to number 5 because that's more interesting. Number 5 is what percent of zip and state fields are switched, right? So what we want to do is find out. So we already know some of them are left blank, but we want to find out which ones are switched. So this can happen when you're collecting data. Let's say there's a front-end system that is collecting data like a website or something, but they just made a mistake and they mislabeled their fields. So all of everything you got from that particular user interface is broken, but you get your data from a bunch of different places and it's not broken from other sources. So this is common with big data because it's such a large amount of data and it's usually aggregated from multiple different places, right? So what we want to do is we want to look at the data and see if we can find these items that are swapped, right? And so we can say swapped. How many are swapped? All right, first let's duplicate this, and this is problem 5. Getting ahead of myself here. All right, problem 5. We want to calculate the number of swapped values. Okay, so how do we want to do this? We have our customers. We could basically use a generator or a list comprehension. Either way, we're going to cycle through the whole thing, so it doesn't matter. But the difference between a list comprehension and a generator is the list generates all the values immediately, so you're storing them all in memory. If we're going to sum these items up, then we don't need them all stored there right away. We can generate them one at a time and it'll save memory. So that's when you want to use a generator. I'll show you what I mean here in a second. So the swapped values here that we have is basically for each record in our records. So for each one of our customers, if the state field is an integer and then the zip field is in a list of states, right? If we have in our utils files, if we have a list of states, then we'll know that those things are switched, right? So if we have an integer, and if we wanted to be more exact, we could say if we have an integer greater than, so there's 5 digits to the zip code. So if we have an integer greater than 10,000, and less than 100,000, that's a zip code. It's 5 digits, right? Or we could convert it to a string and see if it's all the characters are digits. There's a number of different things we can do. So it kind of depends on how your data is broken. If you know why the data is broken a particular way, you can make a better decision about how to fix it. In this case, we happen to know that they're just switched, so we don't have to really put too much detail into how we fix the data. All right, so basically what I'm going to do is I'm going to have I'm going to add a value of 1 for each customer if that customer, if the type of the customer data at the state field, so if the type of that is an integer, and also customer zip is in our list of states. All right, so we don't have states yet. States is going to be something that we import from utils. So we have to figure out how to make this states file. All right, so this is pretty easy to do. You can go online to do it. Just copy and paste, generate some sort of dictionary. It doesn't really matter as long as the dictionary you create is accurate. So I've got this saved already, but what we can do is, let's see, go into utils. Down here we can have states. And what we want to do, because we already know we're going to need that translation layer anyway, where we convert the 2-letter state codes into the big, longer state name, right? So I've got this pre-made, so you don't have to sit there and watch me do this. But you can do this manually, or you can also do this programmatically. There are libraries. There's a library, a Python pip module called US, and it allows you to generate, convert 2-letter state codes as state information. Right, so this is pretty easy to do. So we're going to add this states dictionary, and we want to check to see if in here our customer zip is in states. Oh, there it is. I already had it there. States and dot keys. This states is a dictionary. Okay, so this is a generator that's going to generate the value 1 for each record, each customer record in our customers list, if the customer type of state is the integer, right? And then the customer zip is in our states. So that means probably that the state and the zip have been swapped. And so what I can do then is use the sum function and pass in swapped, and that should give me the number swapped. All right, so this is at first a generator, and then the sum function takes in a list or any other kind of generator, and it goes through and sums up all the values in that collection or that generator, the numbers that the generator produces. All right, so if we made this like this would be a list comprehension. And it's going to give us the number 1 every time we locate one of these things. So this is going to be a list of some number of 1s, and then we're going to sum them all up. That's all we're doing. And instead of having all of those 1s exist in memory, we don't need them to all exist in memory at the same time, because we're dealing with big data. We need to be concerned about that sometimes, so we're going to use generators here instead, and then generate them one at a time as they're needed. Right? This is a small thing. It's not that big of a deal, but in big data, it can become a big deal. So you want to try to use the right the right thing when you can. So we have this swapped value. So how many were swapped? So swapped divided by length of customers, right? These are the swapped state and zip fields. All right, and we should be able to run that. 1.3%. We'll double check that. $17. If we look at our answers file, there 17. So that's correct. So we'll make sure it's the percent because that's what the question's actually asking for, and we'll get that answer file fixed up. All right, so you can kind of see once you get one, you can kind of do the others, but you have to consider, what's the best way to go about these. And the first 5 there is about, missing data, bad data, and in data science, a lot of the times you have to fix some of those things. Sometimes it's not fixable, and sometimes if it's not fixable, you just can't use those entries. Or sometimes if that's not reasonable, you might kind of take an average. Like if you were looking at temperature data and you had a before day and then a missing entry and then the day after, you might be able to interpolate and say, okay, well, the temperature's probably right in between those two, But you need to be careful about that whenever you do modify your data like that. You need to be explicit and explain that you did that because it could potentially change the outcome depending on what you're trying to solve, what problems you're trying to solve. So if you've done that a lot of times, then your data might be a little bit smoother than it otherwise would be, right? And that might affect something that you were trying to study. All right, so cleaning data is very important, and that's what those first 5 problems were about. I'll do some videos on 6, 7, and 8. Let's see, what are the questions here? So the monthly sales data, we'll do some of these in the next video, and then some annual data. All right, so that's all there is for this one. Thanks for watching.